Okay, I'm briefly gonna try to explain oxidation reduction really quick. It's super easy to remember which one is which because we remember oil rig. Oxidation is the loss of electrons, and reduction is the gain of electrons. So what that's meaning, we know that electrons are negative. So if we're losing electrons, then we are becoming more positive. Because if we're losing negative charges, we're becoming more positive. And with reduction, we're gaining electrons, we're gaining more we're gaining electrons, we're gaining more negative charges. So we're becoming more negative. So that's the base for that. So looking at a sample equation, we can figure out, first we need to figure out charges. Because there's no subscripts down here, just like there are over here, we've got to look at the periodic table to determine what the charge is of sulfur. So if we look over here, we find sulfur right here in the 16th group, and we can figure out the charge very easily. The 18th group are 0. It has a 0 charge. 17th group has a -1 charge. 16th group has a -2 charge. 15th group -3 charge, and so on, or at plus or minus 4 for the 14th group, +3 for the 13th group, and so on. So sulfur, 16th group, we have a -2 charge. So you gotta look at the periodic table for that. So we're gonna have a -2 right here. Because there are no subscript numbers like there are right here, we know that there's one copper ion and it has to have a +2 charge to cancel out this one sulfur ion of a -2 charge. Because there's no subscripts, no superscripts, nothing to determine the charge, so we have to assume that it has a 0 charge. So if the sulfur has a -2 charge from the periodic table, the copper has to have a +2 charge to equal that out. Hydrogen, there's no superscript up here to say, +2, -3, whatever. So even though it's, there's 2 hydrogen atoms here shared by a covalent bond, it has a 0 charge. Same thing here with this copper. There's not a +2 or not a +4. We can't look at the periodic table and determine its charge, but if it had a charge, a cation or an anion, it would have a -2 or a +3 up there in the superscript. So it has a 0 charge. The easiest way for me to do these kind of compounds is to just crisscross the charges. So this 2 would become up here on this sulfur up here, and because there's no number down here, let's say if it was a 4, I would move it up here for a +4 charge for the hydrogen, but there's nothing down here, so the 2 moves up here for a -2 charge for sulfur. And because we have to equal them out, we know that there's 2 hydrogen atoms or ions here. So if each hydrogen had a +1 charge, because there's 2 of them, +1 + 1 equals 2, a +2, then a -2. That cancels each other out. So now we determine our oxidation reduction. We look at copper. It goes from a +2 to a 0. We're gaining electrons because it's becoming more negative. If we look back at oil rig, we're losing electrons, gaining electrons. We just gained electrons. So the copper is being reduced. Let's look at hydrogen. We're going from a 0 charge, to a +1 charge, sorry. Because we're becoming more positive, we're losing electrons. We look at oil rig, loss of electrons, oxidation. So the hydrogen is becoming oxidized. Now, if we look at sulfur here, we don't need to worry about it because it has a -2, -2. Didn't change. So now we can say the copper is being oxidized, hydrogen is being reduced. Because, copper is being reduced, hydrogen being oxidized. Because hydrogen is being oxidized, we can say that it is the reducing agent because it's making the other one being reduced. Same thing with copper. Because copper is being reduced, we can say it's the oxidation agent because it's causing the hydrogen to be oxidized. So hydrogen is being oxidized, it's the reducing agent. Copper is being reduced, it's the oxidizing agent. Oxidation, whatever you want to call it. It's causing the other ion to be oxidized. Hydrogen is causing the other ion to be reduced, reducing agent.